Go ahead and knock this out. So the top of our cosine ratio is the dot products that was stuff from yesterday. Remember, dot products is always a single number. And then down here is going to be the magnitude of both of those vectors multiplied together. And just remember, the magnitude is a squared plus b squared. And I'm not even worried about simplifying roots or anything because we're looking for angles. So I'm just worried about the degrees. So the way that we're going to find the angle in between the two vectors is we're going to use the dot products for the top. So this is going to be 3 times 4. That's going to be a 12. And remember, you always add on your dot products. And the second component's 2 times 0. That's just a 0. So the numerator on this is just going to be a 12. For the denominator, so it's going to be the magnitude of angle U, which is 3 squared plus 2 squared, times the magnitude of V, which is 4 squared plus 0 squared. And that kind of looks silly, but I just want to line it all out for our first example here. Back to our first magnitude. Remember, this is 9 times 4, or 9 plus 4. So the magnitude for vector U is the square root of 16. The magnitude for vector V is the square root of 16. And I know that's ugly and that's a little uncomfortable seeing it like that, but I'm looking for degrees. So I don't really care about simplifying this at this time. So also remember, when you multiply roots, you can just write one root and multiply them under that root. So this is going to be 13 times 16 down there. And then I'm just going to type that in exactly like that on the calculator, get a decimal. All right, 12 divided by the root of 13 times 16. So you should have got 0.832 something. That's good. That's the cosine ratio, but we want the angle. So second cosine, second answer. So the degrees created by vector U and vector V, it creates a 33.69 degree angle. And that's how we do it. Let's do it again. Number 2 is in linear combo form, but it's pretty much the same thing. So U is 2, negative 3, and V is 1, negative 2. So I'm just going to use my dot products. Find those two magnitudes down there. So 2 times 1 is 2, plus a negative 3 times a negative 2 is a positive 8. I'm sorry, it's a positive 6. It's going to turn into an 8. I went a little too fast there. The numerator is 8. The denominator, the first magnitude, is going to be 2 squared plus negative 3 squared. The second magnitude underneath this root is going to be 1 squared plus a negative 2 squared. So again, this is 4 plus 9, so it's going to be the square root of 13 is that one, times, this is going to be a 1 plus 4, so it's going to be times 5. All right, turn this into a decimal. 8 divided by that product. If you got 0.9922, you're probably on the right track. Second cosine, second answer. And this has a small degree. This is just 7.13 degrees. Any questions on that? All right, so bless you. We are now going to find the angles of a triangle created by these three ordered pairs. I am going to plot this, but then I'm not going to look at the triangle ever again. I'm just plotting it for a demonstration. When you go to do this on your own, you're not even given a graph to plot it because you don't really need a graph. All right, but we are going to graph it this time. So let me plot these ordered pairs. 1, 2, 3, 1, 2, 3, 4. And then Q's 1, 7. All right, so there's 3 vectors here. And the directions are asking what the interior interior angles they are as they make them and they intersect. So we have 3 interior angles because we have 3 vectors that intersect. So we're going to find angle P, angle Q, and angle R. When we find these angles, if you notice, guys, these were ordered pairs. They're not vectors. We have to find the vectors. So when we find the vectors, the angle is the initial point. I'm just going to write that. The angle is the initial point. Which means when I go to try to find angle P, I'm going to start with the letter P, like this. I need to find P to Q, the vector. Notice how I wrote P first. If I'm looking for P, I write P first. And then I need to find PR. If I'm looking for angle Q, then I'm going to be looking for angle QP and vector QR. If I'm looking for angle R, then I'm looking for RP, then I'm looking for RQ. Just remember, vectors have size and direction. The direction of PQ, I just want to point out, the direction of PQ is a completely different direction than RQ. They're going in different directions. They're going to have the same magnitude, but they're going to have different directions. Okay, let's go ahead and get started with angle P. Here we go. Just going to draw my angle brackets because it's all about component form. So component form for P to Q, I'm just going to analyze these ordered pairs. P is at -3, -4. Q is at +1, 7. So if I start at -3 and I go to +1 for Q, that is an increase of 4. For the second component, if I start at -4 but I go all the way up to a +7, that's a big increase of 11 spaces. Now let's analyze P to R. -3 to +8, that's another big jump of 11. And then -4 to -4 to a +2, that's an increase of 6. Now everything else is like the top part of the paper. So we're going to find the dot product first, and then we're going to find the 2 magnitudes of these vectors. So the top is going to be the 2 A's multiplied together plus the 2 B's multiplied together. So 44 plus 66. Magnitude of PQ. So remember, that's going to be 4 squared plus 11 squared. Magnitude of PR is 11 squared plus 6 squared. So kind of cleaning this up a little bit. 44 plus 66, that's going to be 110. That's our numerator. And our denominator, this is 121 plus 16 under there. Let's find that out. So 121 plus 16. So we know the first magnitude is 137, the root of 137. The other magnitude is 11 squared plus 6 squared. So the other magnitude is not that. Second insert. It is the square root of 157. So remember, you can write one single root symbol, but we're going to multiply 137 times 157. All right, let's go ahead and do that math in the calculator. So 110 divided by the square root of 137 times 157. So you should get 0.75 before you do second cosine, second answer. So angle P is going to equal 41.41 degrees. Now remember, direction is going to be different, but the magnitude is the same. So when I go to find the magnitude for QP, I'm going to cheat a little bit because I know it's the same magnitude of PQ. So you're going to see me write 137 because the magnitude is not going to change. The direction changes, but it's still the same size. All right, let's go ahead and knock out this component form. Let me draw my angle brackets. All right, here we go. Q to P. Q to P this time. 1 to a negative 3, that's a decrease of negative 4. 1 to a negative 4, that is going to be, 7 to a negative 4, that's going to be a decrease of 11. Now Q to R. Q to R, that's going to be an increase of 7 and a decrease of 5. All right, numerator time, dot product time. Negative 4 times 7 is a negative 28, plus the products of the second components, that's a positive 55. All right, here we go, guys. The magnitude of QP is the same exact magnitude of PQ. So this first magnitude is 137. I have not found any R or Q, so I know this is going to be 7 squared plus negative 5 squared. All right, let's figure out the numerator real quick. So 55 minus 28. So our numerator is 27. Our denominator is 137 times 49 plus 25. 49 plus 25 is 74. So angle Q, make sure you got 74.75 degrees. And for the last one, guys, for the last one, you could do 180 minus these. But if you just want to make sure you're set on the calculator, can you please go ahead and find angle R? And you should get 64.15 degrees. Make sure you get that for angle R.